So let's go ahead and just start off briefly with your background. Maybe just tell us a little bit about yourself.
So yeah, my name is Ahmad Beirami, and until very recently I was leading a research team in Google DeepMind around what's called post-training of language models. Post-training is the last mile delivery where everything comes together and the Pareto frontier of model capability, be it coding, be it instruction following, safety, and everything else comes together. And basically, what we were doing was to design new reinforcement learning algorithms as well as reward modeling best practices and putting everything together, putting rewards together, aggregating the rewards, and trying to get the best models out. And we were able to make contributions to Gemini models, as well as some that went into other parts of the Google kind of ecosystem. By background, I'm educated in electrical engineering all the way. I did my bachelor in electrical engineering at Sharif University. Why electrical engineering? I think electrical engineering was what everybody was doing when I went
Mm-hmm.
to the bachelor program. I didn't really think about what I was excited about. Like if I go back and do it all over again, maybe I will actually do double major CS and math. But yeah, so I ended up doing electrical engineering because of some herd mentality. And in my second year in undergrad, I actually took an information theory class, uh, which is right after I had done probability. And I fell in love with information theory. I think information theory, I felt it provided a lot of great tooling for studying interesting phenomena, and like that I really liked the information variable, which is basically the negative log likelihood of probability of some basically outcome when you have a distribution, and how actually studying different moments of information, like basically the expected information is the entropy, and so what the operational meanings mean, and so on and so forth. And so when I was finishing my undergrad, I also started looking into like different things. I started looking into low noise amplifiers. I did some work in photonics. Believe it or not, the first ever paper I wrote was about actually photonics and transmission lines. So I'm not a machine learner
Mm-hmm.
by any meaning of the word. And I started grad school actually doing some photonics, and then I realized that I actually wanted to do information theory. So I took a step back and did my PhD in information theory. This was very hardcore, mostly mathematics. So this is pre-deep learning era,
Mm-hmm.
and I was trying to design like statistical codes for compression of network traffic. We were able to design some very cool algorithms for this kind of compression. This is basically my years at Georgia Tech, and it was fun to be able to actually get time to think about problems for longer time horizons. I think there was one specific problem that I thought about for 2 years, which is quite rare these days. I think everybody wants to finish projects in months, if
Mm-hmm.
not days. And towards the end of my PhD, some compression algorithms based on deep learning came out, and they blew everything off the water. And I got interested in understanding what deep learning was. And in the beginning, I had no tools to actually understand them. So I started trying to think about why do they work and why do they generalize, given that deep learning models pretty much are over parameterized. Back then, we didn't even have the tools to study them. So that's basically kind of how I got interested in machine learning. So I did some work around generalization. It's still very, very, very theoretical. So studied these things during my postdocs. I spent a few years at Duke, MIT, and Harvard studying core information theory as well as some like theoretical ML problems. And I wrote my first NeurIPS paper in 2017 and went to NeurIPS 2017. And then NeurIPS 2017 was unlike any information theory conference I had been to. It was more of a party than than a kind of a conference. So I was invited to so many events by companies and met a lot of people. There was a lot of cool things happening. That's the year that the Transformer paper was published, but obviously I didn't even understand the importance of that work back then. And that's when I got more and more interested into the more empirical and aspects of ML, and so started looking into actually deep learning, and that led me to go to electronic arts. And the reason I went to electronic arts was to try to look at RL in games. Basically, that's kind of how I positioned it. And so started looking at RL in games, but generally also ML in gaming. And we ended up doing some interesting stuff around trying to get RL agents running into games for playtesting and some other things that I learned about. And by 2019, I realized that transformers had staying power, and so I think the kind of a lot of NLP traditional NLP problems were falling one by one, and I thought it would be cool to combine decision-making processes like imitation learning, reinforcement learning with basically the language models. And that's why I moved to Meta, to basically in the AI organization, to start a new project around that. And the test bed that I thought what made sense was to try to basically build an assistant using language models, and basically through some imitation learning and reinforcement learning, and using a language model with tool use capabilities. This is end of 2019, early 2020. It was a moonshot, and it was considered crazy by some people. And I think there was a lot of questions about how are you going to represent state? Like, this is never going to work. And we very quickly were able to get a prototype running, and so started actually trying to get this thing into production. And so we were like, there was a lot of problems back then. We were still fine-tuning the models because like prompting wouldn't work. Like, this is like GPT-2 era. And we were working with BlenderBot. My colleague Stephen Roller, who was basically leading BlenderBot, and so we were trying to fine-tune BlenderBot for these task-oriented dialogue things. But that was like, these were 2B models, and like 2B model back then was considered like, wow, it's like we have our hands on like these huge models that nobody else can actually even touch. And yeah, that was quite a fun era. And then I moved to Google to basically look into safety for language models, and basically kickstart projects in the responsible AI organization around that. And started a kind of small team looking into how to do safe decoding, which basically led to this work we did called control decoding. We launched this in the predecessor to Gemini, which is called BARD. And yeah, through that, then we eventually horizontally expanded to look at more kind of the entire post-training stack and try to figure out like how to optimize different things.
Mm-hmm.
We did some work on speculative decoding to make decoding faster.
Mm-hmm.
We tried to think about how to actually post-train models for better test time scaling
Mm-hmm.
and things of that sort. And a couple months ago, I left my job
Mm-hmm.
to explore agents and
Mm-hmm.
agentic workflows. I think there's a lot of excitement around that. And I think there is still a lot of tooling and basically even conceptual
Mm-hmm.
problems that need to be solved. So that's the area that I'm tinkering with currently.
Mm-hmm. Awesome. So, I mean, thanks for giving us such a great walkthrough of all of the great stuff you've been up to. So maybe we can spend a little bit of time going to some of your papers. So, I mean, you worked on a lot of really great papers, so it's kind of hard to, select which papers to talk about here. But I'll sort of, put them into two categories. Like one, maybe slightly older papers that have been like
Mm-hmm.
super renowned. So I think this is where we look into like, for instance, Ditto, fair and robust federated learning through personalization, and another paper titled Fair Resource Allocation in Federated Learning. So these are both from ICML 2021 and iClear 2020. And then on the other side, you have some of the more recent papers. For instance, you have a paper from iClear 2025 that won the Outstanding Paper Award titled Safety Alignment Should Be Made More Than Just a Few Tokens Deep. Have some other papers that are really exciting very recently, like for instance, Infoline. So maybe whichever papers you think are relevant that you want to talk about. The floor is yours.
Yeah, so thank you. So maybe I can tell you a little bit about the kind of the so you mentioned two works around federated learning,
Mm-hmm.
and so I think those collaborations forged because Tian Li, Virginia Smith, and
Mm-hmm.
Maziar Sanjabi were actually looking at these problems and they were trying to improve safety
Mm-hmm.
and robustness in the
Mm-hmm.
federated learning context. And
Mm-hmm.
this is back in 2020. I was at Meta. I was very, very excited about
Mm-hmm.
fairness and robustness, and we were seeing a lot of fairness and robustness issues in basically language modeling, tool use aspects of language models. So I thought it would be good to try to actually more broadly look into the RAI aspects of ML. And those papers basically started with them having some algorithm that was giving some good results, which is basically the QFFL paper. And I was trying to theoretically understand what was going on.
Mm-hmm.
So that theoretical investigation led to actually what we published later in iClear 2021, which is
Mm-hmm.
called tilted empirical risk minimization.
Mm-hmm.
So we were able to actually take a step back and relate that to information theory
Mm-hmm.
and basically the spectrum of information of a random variable and
Mm-hmm.
be able to say why and when you can actually train for robustness or train for fairness
Mm-hmm.
rather than just doing empirical risk minimization, which is the usual framework that everybody uses for training. And then we were able to actually through that come up with an easy tweak, if you will, of
Mm-hmm.
like we basically one hyperparameter where it's also um, uh, that has a meaning. Basically, when
Mm-hmm.
you make that hyperparameter zero, it's just traditional ERM. For positive values of hyperparameters, you're going to highlight the outliers in your training set.
Mm-hmm.
And for negative values of that hyperparameter, you're going to basically suppress the effect of outliers in the training set. So as you can imagine, intuitively, the positive values bring fairness
Mm-hmm.
and try to actually highlight the difficult and challenging samples. On the other hand, the negative values of the tilt hyperparameter
Mm-hmm.
make the outliers go away.
Mm-hmm.
And so that's basically the story of those papers. You
Mm-hmm.
also highlighted the safety alignment should
Mm-hmm.
be made more than a few tokens deep. I think that work is mostly driven by Xiangyu Shi
Mm-hmm.
and Peter Henderson and their collaborators at Princeton. Basically, I think Xiangyu had this hypothesis that the safety alignment has basically a shortcut.
Mm-hmm.
And so he already had the hypothesis, and so we
Mm-hmm.
started looking into like how to actually validate the hypothesis, and so my contribution was more towards the design of algorithms for mitigating
Mm-hmm.
that issue
Mm-hmm.
through some token wise losses and so on.
Mm-hmm.
And you also mentioned Infoline. So the
Mm-hmm.
Infoline work is basically our latest work that tries to ask the question of actually a very simple question. So when we train RL,
Mm-hmm.
generally we are optimizing expected reward, right? So that
Mm-hmm.
expectation is with respect to the policy that we are optimizing.
Mm-hmm.
So implicitly that assumes that you're sampling from the model.
Mm-hmm.
We're no longer sampling from the model. We are
Mm-hmm.
doing a lot of different things, right?
Mm-hmm.
At the very least, we may be generating a bunch of samples and
Mm-hmm.
picking the best one. We may be
Mm-hmm.
doing self-consistency. We may have
Mm-hmm.
an agentic loop. We may
Mm-hmm.
have a lot of different things. Or like if you're thinking about safety, we're not an adversary is not simply sampling from the model. Maybe they're generating 100 samples
Mm-hmm.
to jailbreak the model.
Mm-hmm.
And so the question is, how should we think about alignment
Mm-hmm.
in a world where we're no longer sampling from the models? And it
Mm-hmm.
turns out that for actually some class of what we call inference time procedures,
Mm-hmm.
the solution is pretty simple. Like for example, if you're doing best of n
Mm-hmm.
at inference time, which is equivalent to a lot of these other test time procedures are actually as good as best of n.
Mm-hmm.
And so I think I've been a big proponent of
Mm-hmm.
best of n.
Right.
Like whoever, yeah, whoever has been listening to me, I think
Yeah.
may attribute me with maybe yeah, no, their embeddings
Mm-hmm.
will will put me on best of n,
Mm-hmm.
very close. So basically, if you're doing best of n, it turns out that you can actually tweak this objective very simply and
Mm-hmm.
try to highlight and focus on higher quantiles of the reward
Mm-hmm.
for training.
Mm-hmm.
And it turns out that focusing on higher quantiles of the reward
Mm-hmm.
comes back full circle to this idea of tilted empirical risk minimization.
Mm-hmm.
It's just basically you're tilting the reward distribution.
Mm-hmm.
And so basically it's going to be an exponential tilt again.
Mm-hmm. Awesome. Yeah, thanks for walking us through that. So, I mean, you talked about, your deep, unwavering belief in best of N. Aside from best of N, are there some other, thoughts that you have just generally about really anything related to ML research, sort of thoughts that you feel like you've held for a long time? And then also, critically, I mean, your work has sort of, spanned a few different regions, right? So we talked, briefly about some of your work in federated learning with Virginia Smith, who's obviously incredible, along with some of your more recent work that you've been working on. What are your sort of thoughts on the current areas today that you think are relevant? Any things you sort of want to highlight to the audience?
Yeah. So I think there is one piece of advice I've
Mm-hmm.
been giving everybody,
Yeah.
and that is look at your data.
Mm-hmm.
And if I'm going to give a second piece of advice, it's also look at your data. I think
Mm-hmm.
a lot of us train models and basically evaluate them and get some numbers
Mm-hmm.
and move on without ever looking at the data.
Mm-hmm.
I think that's extremely important. When we basically set up a problem,
Mm-hmm.
then we get some algorithm running, it's very important to analyze
Mm-hmm.
where it's breaking, where it's working well, and
Mm-hmm.
so on. Or like basically, if we come up with a new algorithm, it's very important to analyze the actual strengths and weaknesses
Mm-hmm.
compared to another algorithm and actually get a good understanding of what is happening.
Mm-hmm.
I think this is critical because it's going to actually enable us to ask the right questions,
Mm-hmm.
because having this deeper understanding will give us will lead us to good questions to
Mm-hmm.
try to answer.
Mm-hmm.
And that brings me to the second thing, is that actually asking questions and defining problems is very important. I think again a lot of us are unfortunately driven by solutions. It's like, oh, I think I can make this tweak to this algorithm.
Mm-hmm.
Okay, so, but what problem are we solving? Like, let's try to actually understand what are some of the challenges and issues that we are facing,
Mm-hmm.
and then try to come up with a solution for those specific challenges.
Mm-hmm.
And so, setting up good problems, it comes from deeper understanding of methods, like
Mm-hmm.
doing the deeper analysis.
Mm-hmm.
It may feel like it's slowing us down, but I think in the long term, we're going to move a lot faster,
Mm-hmm.
because that's going to enable us to do much more efficient exploration.
Mm-hmm.
Uh, so,
Yeah.
what was the second question? Sorry.
Yeah, no, I guess maybe our last question for the podcast. So, I mean, you worked a lot on, RL and inference. For instance, like I think you worked on that at DeepMind. You worked on RL agents at Electronic Arts, which we mentioned earlier. And you sort of, that's part of the reason why you wanted to join EA in the first place. Maybe just tell us a little bit, about your thoughts on RL today. I mean, obviously, we saw some really amazing releases on the RL environment side. There's
Yeah.
some really great libraries and RL verifiers. So a lot is going on here. A lot of people talking about RL as a service, some really exciting startups emerging here. Just what are your thoughts on the
Yeah.
area? Anything we should highlight?
So I think basically getting environments makes a lot of sense, and
Mm-hmm.
so generally unifying the training stack. I think there
Mm-hmm.
is a lot of great work going on in the open source world, and I think the biggest piece here is that the heavy lifting is done by the verifiers.
Mm-hmm.
So generally, I think we've had a lot of success in domains and environments where we have good verifiers.
Mm-hmm.
And basically, we already know with all of the algorithmic improvements that we've had in the past few years, we know how to distill a good verifier back into the model.
Mm-hmm.
But basically, the heavy lifting is done by the actual verifier. It's like,
Mm-hmm.
what's a good verifier?
Mm-hmm.
When the verifier is noisy, when we do reinforcement learning, we're going to actually start deteriorating the model.
Mm-hmm.
And I think RL, there is another piece to RL which I think is not very well appreciated,
Mm-hmm.
is especially in the kind of the language modeling domain, is
Mm-hmm.
that when we're doing RL, we
Mm-hmm.
need to make sure that we're not moving too far away from the pre-trained checkpoint.
Mm-hmm.
And the reason for that is that the 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 kind of the language models we're training
Mm-hmm.
are general purpose problem solvers. These are not kind of very specific, narrow problem solvers like we had in games,
Mm-hmm.
that, okay, I just want an agent that's going to win a game, and winning the game is actually the ultimate reward that I have for this agent.
Mm-hmm.
But here, the agent still needs to be able to comprehend the user
Mm-hmm.
queries. It needs to be able to do some reasoning. It needs to be able to do some instruction following and so
Mm-hmm.
on in order for it to solve the problem. Now, obviously, we want it to be able to solve the math problem.
Mm-hmm.
But if we just over-index on the rewards and do reinforcement learning, what's going to happen is that we're going to actually deteriorate the models in
Mm-hmm.
terms of all of these other capabilities that we're not measuring.
Mm-hmm.
So even if we're like fine-tuning models for downstream tasks,
Mm-hmm.
we still need to be able to capture like this, not drifting too much away from the pre-trained
Mm-hmm.
checkpoints.
Mm-hmm. Okay, awesome. Well, without further ado, thank you so much for coming on the podcast. Really appreciate it.
Well, thank you so much. My pleasure.